We're working on section 3.3, which is to solve multi-step equations. The first step in solving a multi-step equation is you want to get rid of your parentheses, and you do that by using the distributive property. You must combine like terms on each side of the equation, and you need to use the inverse operations or the opposite operations to get variables on one side and the constants on the other. And you're using those inverse operations in order to solve for the variable. So let's get started on doing a multi-step equation. This multi-step equation has two terms that are like terms on the same side of the equation, so let's add them together. 8x minus 3x is 5x, minus 10 equals 20. Excuse me. Now we have a two-step equation. We need to take care of the negative 10, so we're going to have a positive 10 added to both sides. That'll leave us 5x equal 30, and then we can divide by 5 on both sides and have x equal to 6. Put a box around that answer, please. If you want to check to make sure that this works, you can definitely substitute that 6 in for each one of the x's, and then you would go through and calculate the numbers. 8 times 6 is 48, 3 times 6 is 18, and as we're subtracting here, 48 minus 18 is 30, and then 30 minus 10 equals 20, and we get down to a true statement. Excuse me. Alrighty. Let's keep going here to our next equation. And we have some parentheses. We need to do a little bit of distributive property here first. So we'll have 7x plus 2x plus 12 equals 39. And we'll add our like terms together. So 9x plus 12 equals 39. Subtract 12 on both sides, so that you're left with 9x equal to 27. And then we can divide by 9 on both sides and have x equal to 3. All the way along, we're using inverse operations. Third example, let's take care of our like terms again. This will give us 7x plus 4 equals 32. And then we can subtract 4 on both sides and have 7x equals 28. And when we divide by 7 on both sides, x will be equal to 4. Our set of parentheses needs to be taken care of. The 3 is times the x, and the 3 is times the 4. So we'll have 2x plus 3x plus 12 equals 27. Add your like terms together. 5x plus 12 equals 27. And then we can subtract 12 on both sides and be left with 5x equal to 15. And now when we divide by 5 on both sides, x will be equal to 3. When you have a problem that has a fraction outside the parentheses, technically you could distribute that, but then you're going to deal with a whole bunch of other fractions. So let's go ahead and multiply by the reciprocal on both sides of the equation. That way, these will cancel out, and we're left with 3x plus 5 on the left side, and on the right-hand side, we can think of this as 24 over 1. 3 cancels into 24 8 times, and we'll have 8 times 2 is 16. We have a negative in front of that 24, So that means it'll be a negative 16, because that's a negative times a positive. Now we can continue on and work through our opposite operations, our inverse operations, which will give us 3x equal a negative 21, divide by 3 on both sides, and x will be equal to a negative 7. Make sure that I'm seeing each step along the way. That is an expectation. Number 6, we have that fraction again. So let's go ahead and multiply by 4/3 on both sides. The two fractions will cancel each other out, so we're left with x minus 6. And on the left-hand side, again, if you think of that as over 1, we can do a little canceling, and that'll give us 4 times 4, which is going to be 16. Now we can just add 6 to both sides, and we'll have x equal to 22. One of the things that we can do here is write and solve a multi-step equation. When we're looking at the perimeter of a triangle, we think about the perimeter of a triangle formula is all 3 sides added together. And we know that the total perimeter is 24 feet. So that 24 feet is going to get put in for the capital P, and then we have all of these sections over here that are going to be our A, B, and C. So if we write an equation to model this, that means I'm going to have 24 equals x plus 4 plus 4x plus 10 times x minus 1. Let's go ahead and combine our like terms together. So we simplify the right-hand side. We have our x and we have our 4x, but we've got this 10 that has to have a little bit of distributive property done to it. So we're going to write 24 equals, and I can add the x and the 4x together. That's 5x plus 4, and then I need to take care of that distributive property and do 10x minus 10. Now I can add together just a few more like terms. 5x and 10x is 15x, and 4 and negative 10 is a negative 6. Now I've written an equation that models that situation as simplified. This is where we started out, and this is where it's simplified to. In order to find that value of x, we are going to use our inverse operations. We're going to add 6 to both sides. And we'll extend a little bit here so that we have 30 equals 15x. And then we can divide by 15 on both sides and find out x equals 2. Please notice there is no label put on this because we're just finding what the value of x is. That is not finding the actual length of a side. One more problem in finding the perimeter of a rectangle. This one is 26 meters total. And we know that the perimeter is 2 times the length plus 2 times the width. And this 26 is what's going to be put in for that capital P for perimeter. So I have 26 equals 2 times, well, one of them is going to be x plus 3, and then the other one is going to be 2x minus 6. So let's simplify that a little bit. We've got double distribution property there. 26 equals 2x plus 6 plus 4x minus 12. And when we add our like terms together, that gives us 6x minus 6. This is our equation that's giving us the situation that we're working with. Now we're going to solve that equation. We'll add 6 to both sides, and when we do, that gives us 32 equals 6x, and when we divide by 6 on both sides, x is going to be equal to 32 divided by 6. Well, I can simplify that fraction down to 16 over 3 because I can divide both numerator and denominator by 2. And we can leave it just like that. Could you write that as 5 1/3? Yes, you can, but I'm perfectly fine with leaving that as an improper fraction. Good luck on your homework for this section. Come see me if you need some help.